In question 12, we are solving an applied problem using a quadratic function, or parabola. So we got a rancher who is going to fence in a rectangular pasture. They got 400 meters of fencing. And we're going to write the area A of the pasture in square meters as a function of x, which is the length, and then of the side that's parallel to the river. And then what's the domain of A, and then find the exact dimensions that yield the maximum area. And maximum area, that's going to be at the vertex. So part A here, area is length times width. And our length is x. So they're telling us to call length x. So this will be x times w. So we need to find the width here in terms of x. And this is a pasture that is bordering on the river here. So here's the river. And then we are fencing in like this. So our length is x, and then our width here. So we have 400 feet of fencing. So in the fencing is going to be a width, an x, and another width. There's no fencing here along the river. So maybe erase that x. So we are given here that 2w plus x is equal to 400. Because they told us here 400 meters of fencing. So then that means that, let's see, we bring the x over as a negative. So 2w will be 400 minus x. And then divide both sides by 2. So our width will be 400 divided by 2, 200 minus x over 2, or 1/2 x. So now we can go ahead and plug in for w. So this would be x times 200 minus 1/2 w. I'm sorry, 1/2 x. And then we can simplify that a little bit if we want to by multiplying the x in. So this would be 200x minus 1/2 x squared. So there's our equation in terms of x. Part B, what is the domain? So the domain here in part B, we need to have our length here, which is x, be greater than 0. And we also need our width here, which is 200 minus 1/2 x, to be greater than 0. So x needs to be greater than 0. Let's see, if we bring this over as a negative, that will be 200 is greater than 1/2 x. And then let's see here, multiply both sides by 2. And then these 2's cancel. So we get 400 is greater than x, which is equivalent to x is less than 400. So x has to be greater than 0 and less than 400. So what we need is 0 less than x less than 400. So x has to be between 0 and 400. And then part C, find the exact dimensions that yield the max area. So that's at the vertex. So for part C here, the x-coordinate of the vertex is negative b over 2a. for our parabola, and that is written here. Now if we write it in standard form, we'd write -1/2 x squared plus 200x. So our a is -1/2 and our b is 200. So negative of b is 200 over 2 times -1/2 is our a. Double negative will make a positive. These twos cancel. This is just 200. So x is 200, and that's your length. And then your width is going to be the 200 minus 1/2 x. So 200 minus 1/2 of 200. So that's going to be 200 minus 100, 100. So length is 200 and width is 100. Oh, also here in part B, they wanted us to write our answer in interval notation. So in interval notation, that would be 0, 400, and those would be parentheses. And that wraps that one up. Oh, but while we're at it, let's go ahead and find that maximum area. So our max area is going to equal the function value at 100. So our function value was the -1/2 x squared plus 200x. So this will be -1/2 times 100 squared plus 200 times 100. And that is 20,000. Now on the exam, they also ask you to graph this parabola here. So we've got that vertex, we've got 220,000 is the vertex. So 200, 20,000. So our equation so remember here that the general equation for a parabola is y equals a times x minus h squared plus k, where hk is your vertex. So for us, that's going to be a times x minus 200 squared plus 20,000. And then we just need to find a, and we know that when x is 0, y has to be 0. So when the length is 0, the area is 0. So x equals 0. If we plug that in, we get y equals a times x minus 200 squared. So this will be a times -200 squared plus 20,000, which is 200 squared is 40,000. And that'll be times a plus 20,000. And set that equals 0 because we know we have the point 0, 0. So then just solve for a. So bring this 20,000 over as a negative. So then you've got 40,000 a is equal to -20,000. And then divide 40,000 off both sides. So your a is going to be -20,000 divide by 40,000, which is -1/2. So now we can go ahead and fill in our equation, put in the -1/2 right here. So this will be -1/2 x minus 200 squared and then plus 20,000. And then we could graph that parabola if we wanted to. It looks something like this. And at 200 here, we would have a maximum height of 20,000. And you could graph that in Desmos too if you wanted.